this thing. How would I run it? I would go ./WD echo.
And the file name?
And then, well, in this case, it's not a file. It would be
The arguments?
The arguments. If I did that, then so I compile it. How do I compile it? I go GCC
/WD
echo.c -03 -wall then -o WD echo. That's the way I compile it. What does that produce? It produces this function. And I run that function, ./WD echo, and I give it, and what are these? What is this one called within that C code?
That's a function, right?
Yeah, but what's it called in the C code relative to command line arguments? Which command line argument is it?
Argument 0.
That is argv of 0. What's this one?
Argv of 1.
Argv of 1. What's this one?
Argv 2.
Argv of 2. How many total arguments are there?
3.
So therefore, arg count is 3. Do you see it?
Mm-hmm.
Do you see it? So I compile it and then run it. And what should the response be? It should just say, "Hello, Kristen." Correct?
Right.
And so which command line arguments does it dump out?
Argv of 1 and Argv of 2.
Argv of 2. Notice it goes up to 1 less than arg count. Do you see it? Now, if it's the first one, what do I have to put? If it's not the last one, what do I have to put after it?
A space?
A space. Do you see it? So here we go. For I equal 1, I less than arg count, increment I. If I is less than arg c minus 1, that means I'm not on the last one. Then what do? I print f. What does the %s match to?
Strings?
A string. What is argv of I? A string. So it prints out the string and a space. In this case, when I is 1, what's argv of 1?
Hello?
Hello, so it's going to print out HELLO space. Then what happens at the top of the loop? It increments I. Now what does I have? 2. Okay? Is I less than 3 minus 1?
Yeah,
no.
No.
Because I is 2. So I is not less than 3 minus 1. So it doesn't do the first part of the if, it does the else. In which case, what does it print out?
Argv 2.
Argv of 2 without a space. So it prints out Kristen. Alright? And then what does it do?
It goes.
Then it dumps out a new line on line 21, because that's the end of the loop.
Yes.
Then it exits 0. What does 0 mean? False.
False.
So the exit is, it answers the question, was there an error?
No.
And if the exit is 0, what's the answer?
No.
Okay, so that's WD echo. Is it a little clearer now?
Yes.
So let's look at the next command. Okay, let me back up a little bit. So that was WD echo. We're going to look at WD touch. So let's see how touch works. Look at, first of all, you see just underneath hello class, here, let me get my pointer out here. Right here I say, give me a listing of the file called XYZZY. And it shows me that file. In particular, it's got a timestamp right there. Do you see the timestamp is 1337?
Mm-hmm.
So the timestamp is 137. And then when I say touch that file, right here, touch the file, and then I list it again, notice that the timestamp is different. So the touch command either creates a new file if one doesn't exist, or it modifies the timestamp associated with that file. Is it clear?
Yes, but what would be the purpose of that?
There are multiple purposes. I want to ensure that a file gets dealt with. Maybe I've got some process that says I'm only going to deal with new files. I'm only going to deal with files that have been changed since yesterday.
Okay.
And so you would say you would touch the files that you wanted to, and it would be as though they were modified today.
Okay.
And that way they would get dealt with. It's a quick way of creating a new file in Unix.
Okay.
If I wanted to create a new text file, I'd just go touch, Marcus.txt, boom, and it's done.
Is that something what Windows is doing behind the scenes? Windows is doing the same thing behind the scenes?
I'm sure that all operating systems have an equivalent type of capability, yes. All operating systems are going to have some notion of a timestamp, okay? They're all going to have some way of modifying that timestamp. We're looking at Unix in particular, okay, because it's the most prolific operating system. It's the one as a computer scientist or as a computer engineer you ought to just jolly well know about when you get out in the industry. Otherwise, people are going to want to know where you bought your degree. And that's the bottom line.
Phoenix?
Okay, so we're going to now implement a watered-down version of touch. So, first of all, looking at the way touch works here, how many command line arguments is it going to need? In the C sense? Two. It's going to need the touch command itself, which is argv of 0, and then it's going to need the file name, which is argv of 1.
Okay.
What's argc going to be in this case?
It's
2. All right? So let's reason about what touch is going to have to do. The first thing it's going to have to do is declare a bunch of variables. It's going to then try to check how many command line arguments there are supposed to be. And if they're wrong, it bails. If they're right, then what's the next thing it's going to try to do? What does it assume argv1 corresponds to?
The function?
The file name.
The name of the file. So it's going to try to do what to that file?
I keep forgetting my zeros.
It's going to try to open it, make sure it's a legitimate file. If there's no such file, what's it going to do?
It's going to
It's going to create that file.
Not anymore. Should have said first initialize a bunch of variables.
Yes.
Why does it need to initialize those variables?
So what it's going to declare and or initialize. It's going to declare / initialize.
Why would it do that?
Well, it may not be. It's not always necessary to initialize variables, but in C, it is necessary to declare variables always. It's not like MATLAB or BASIC or Fortran or some of the other sloppy languages where you can just start using a variable without declaring it. In C, you have to declare all variables.
So what variable can we declare?
Well, let's take a look at the actual code. So remember, the concept is what? We're going to check for command line. We're going to declare variables, initialize them if necessary. Okay, check command line argument count. If it's correct, then we're going to attempt to figure out what to do with that thing called file name, namely argv of 1. If it's an existing file, what are we going to do?
Change the
You're
timestamp.
going to update its timestamp. If the file doesn't exist, what are we going to do?
We're going to create a
You're going to
file.
create an empty one. So those are the requirements for this watered down version of touch, which we will call WD touch. So let's take a look at the code that does that. Are we ready?
Mm-hmm.
All right. So here we go. So notice that WD touch requires command line arguments. Hence, main int argc, comma, char *argv braces. So it needs both of those. Anytime you have a C code that uses command line arguments, line 10 is going to be in your code every time. If it uses command line arguments, line 10 is going to be there, flat out. Okay? In this case, I only need a single object called OFP. And I've identified it as a pointer to the file that will be touched. So why didn't I call it Fred? Why didn't I call it Maurice? Why OFP?
Just identify it.
Why OFP?
Is it?
How about output file pointer? So in programming, you try to use names that are indicative of the purpose. Okay? So OFP is output file pointer. Anytime you're going to open a file, whether it's read or write, it's going to be file star name, whatever the name is of the pointer. All right? Now, look at line 15. What am I doing here on 15?
If it's not 2,
What does that mean?
that if it's not 2, then you want to create some kind of message and close.
Yes. So I tell them, hey, here's how you use the thing. WD touch file. So I print that message out. And then what does exit 1 tell the operating system?
That it was,
What does 1 mean?
it's
One-
false.
No,
I mean,
1
true.
means
False.
not false.
Not false. Okay.
Which must mean, so operating system might be asking, was there an error? And if it
No.
gets exit 0, was there an error?
No.
Yes.
If it's 0, it's an error?
No. The operating system asks the question, was there an error?
Okay.
And if the answer's not 0, that means yes, because it means true.
True. Okay.
So exit 1 tells the operating system. Now, the operating system may not be doing anything with it, okay? It might not be doing anything, but if you had a script file, then you might be checking, oh, if this thing returns error, then do something different, right? In this case, we're simply returning to the operating system true, saying something bad happened. Now, assuming that line 15 doesn't fail and it doesn't execute the body of the if statement, what can we proclaim at line 20? They have how many command line arguments?
2.
2 of them. What do we now need to do? You now need to open or create the file. And here's the magic here. If you open a file for append binary, then one of 2 things will happen. It'll either open the file if it exists without destroying it. What's the problem if I do this? Let me just illustrate this again. What if I had a file called oops and I did that? What would happen to oops? It would be destroyed and a brand new empty file would be created. Oops. Oh, this is not good. Right? So, because
Where
if
does that
you,
get destroyed, basically?
the write command, if you open for write, write destroys any existing file by that name, creates a brand new file. You're dead in the water. It goes and unlinks all the inodes and unlinks all the data blocks and unlinks all the indirect blocks and all that junk, returns all that stuff to the operating system and gives you a brand new empty file.
Dr. Morris, what statement tells us if it's what tells us whether it's we need to change the time date?
Well, we're going to get to that in a
Okay.
minute. Right now, instead of opening it for write on line 21, how do I open it? Append, and I'm doing it in binary mode in case it's a binary file. Okay? In case it's a binary file. All right? So append mode allows you to open an existing file, if it's already there, without destroying it. Or create a new file. What happens if I do this and oops doesn't exist?
It's going to create a new
It
one?
creates a new one. So I want it to have the behavior that it either
Is there or not?
either it creates a new one if it doesn't exist, or it doesn't destroy the old one if it does. And the way that I trick the operating system into doing that is by saying, opening it in append binary. The real reason for append binary, if this was my file, what does append mean?
Add something.
Glue it to the bottom, right? So that's the real purpose for append binary is I open the existing file and start gluing stuff at the bottom.
Okay.
All right? So append binary opens the file or creates a new one if it doesn't exist. Now, what if it for whatever reason couldn't open that file or create it?
It will give you that error message and
go
close.
away. That's unlikely to happen, but it could. All right? Maybe you've ran this program from a directory in which you don't have permissions. In which case it will go, I can't create this file. Adios. So, then, line 27 does what?
Closes.
It closes the file. Now, what do I know at line 28 for sure?
If you created a file or...
That either the file exists or I created it. One way or the other, the file's there. And then I simply use the operating system call called update time on the specified file to change its timestamp. All right? So every operating system is going to have some kind of mechanism to change the timestamp. That's the way Unix does it. UTime, standing for update time. Okay? And notice in this case, line 8, if you're going to employ the UTime function call, you have to have access to the UTime header files, where the prototypes and all the declares and defines and all that. So I update it. Now, assuming that, looking at this, what do you suppose UTime returns if it's successful?
The latest
The
timestamp change?
updated time.
Well, in particular, when would I go into the body of this if clause?
Every
If,
time.
Now look
No.
at it.
if
If the file existed.
Well,
you
well,
time,
hang on. If condition under what circumstance does the body of the if clause get executed?
if it's no,
If the condition's true, right? So what do you suppose UTime returns?
0, 1.
It returns an error. It returns true or false. What if it returns false?
Then an error occurred.
That means if it returns 0, that means there wasn't
No,
an
I'm
error.
getting confused again. Not.
I know. Stand up. Yeah. Here, watch. Here's the door.
Yeah.
No, not women's. Yeah, women's.
You so wrong.
That's the right one. Yes. So remember, an if clause, it asserts, it tests the condition. So in this case, what does it suggest should happen here? If you couldn't touch it, what does that mean? There was an error. So what does UTime return? An
Error
code.
message. Yeah.
It returns an error code of some kind, an error code. Okay?
So if it wasn't 1, it's gonna print out the little error code. Then it's gonna exit out the
It's gonna
program.
exit. Right, it's going to leave. If it wasn't 0, UTime returns 0 when it's successful.
Okay.
Okay? It returns an error code. 0 meaning no error. So if you successfully updated it, go home. Make sense? So that's WD Touch. And again, notice how you compile it on line 4. And notice that you needed certain types of includes up there. The standard IO libraries, the standard lib libraries, the utime.h libraries. Okay?
Dr. Morris, how many libraries does C have?
Depends on the implementation. Hundreds of thousands.
Mm.
All right, so
Can we add something to it? Can we make our own library?
sure, it's a common thing to do. People make their own libraries all the time. That's why there's so many. The language itself has no libraries.
Yeah.
Okay, libraries are something you add to allow the code to do something.
Okay.
So here's what do you suppose RM does?
Remove.
Right.
Remove.
Right. So look where it says at command number 569. Command 569 where it says RM XYZZY.
So we're removing that file?
That's deleting the file. So looking at the requirement, how many command line arguments are there for the C? There's 2. What's argv of 0 going to be?
That's
Remove.
The RM command. And what's the XYZZY going to be?
It's arguments.
argv of 1. So what's your code going to do?
Remove
It's
files.
going to put in some header files. it's going to have command line arguments, int argc, char star argv square braces, right? First thing it's going to do after it declares all the variables and initializes those which may be initialized, then it's going to do what? Test the number of command line arguments, which should be in what in this case?
2.
Yeah, so if argc is not 2,
Then it's true.
then you're a big dummy, bye. Otherwise, what are you going to try to do?
Remove the file.
You're going to see if that file exists, right? You have to test to see if the file exists,
Yeah.
all right? And if
So
it
how would you
does exist, what are you going to do?
Remove it.
You're going to throw it away, right?
What would be the line to test if the file was there?
Well,
If
you're going to try to open it. So
Okay.
we'll look at the actual implementation of, not RM, but
remove.
WDRM, because we're doing what? We're doing water now.
So, Dr. Morris, if we did remove this file, would it be like you said about the perverts? It would just still be waiting there for
Contents of the blocks would still be there, yes. So here we go. Here's WDRM. Let's look at the code now. So in this case, I need standard IO, standard live, and string. And we'll see why later. Then I've got this little thing on line 9 called message. Just because I don't want to clutter up my C code with this big long string. I really did it to illustrate that you can use defines to declare, these pseudo.
So whenever something don't go right, it's gonna go back up to define and print that message.
No. It's not going to go up there. It's going to print that message. You'll see.
Okay.
So here we go. So line 11, because we're using command line arguments, a standard thing. Int argc char star argv square brackets. Then I need 2 objects in this case. I need an input file pointer, file, star ifp, and I need an integer called IERR, because we'll see later that the remove operating system function returns a value called IERR. Okay, in this case. We could have called it Fred if we wanted to, but IERR seemed to be more representative of the nature of that error. Right? Could have called it Maurice. Right? So here we go. So what's the first thing I do on line 17?
You're gonna declare?
No, line 17. Look at it.
17. Oh, if 2.
R counts not 2. Hey, you're a big dummy. Bye. Otherwise, what do I know at line 22?
You're gonna open the
The
file.
argument count is correct. So now let's look what I first try to do. Okay? I try to open it in read-only mode. Why didn't I try to do it in write mode?
Because you're not writing.
Well, because if I did it in write mode, it would create it if it wasn't there.
Oh, okay.
Right?
Yeah.
So I try to open it in read mode, and if that's null, what does that mean?
It's not there.
There was no such file, in which case I print out the message that says, I can't remove that file because it's not there. Bye. You see?
Oh, I see how you did it now.
Look up there. Okay? So the message is the first argument to the printf command. So remember, macros are textual substitution. So the preprocessor, every time it runs into capital MSG, it does a copy paste. It does a cut of MSG and a paste of what MSG means, which is that string up there.
Okay.
WDRM cannot remove. What's %S going to correspond to?
String.
String.
Yes. It's going to correspond to a string. And what string do I send it? RV of 1, which is what?
The file name.
The file name that they said to remove. All right, and then we do.
So you're telling me you can't remove this file because it doesn't exist?
Yes, I can't remove the file. I mean, try it in Unix sometime. Go RM, a non-existent file, and it would go, there's no such file, stupid.
Now, Doctor, I have a question here. Now, we could have done that the same, because okay, right. If you do this thing, right, it would remove the data from the file, but the file itself would be there.
Yes, and would create a brand new empty file, which isn't what we wanted to do.
Right.
We don't want the file to be there.
No, well, it's not going to create a brand new empty file. It's going to remove the data from the file, right?
Well, so you say tomato, I say tomato. Okay? What it's going to do is it's going to reclaim all the inodes, data blocks, indirect data blocks associated with the file first. Then it's going to go, I need a new inode. Okay, now it might be the same inode, it might not. Depends on the implementation of Unix, right?
Right.
A clever Unix might say, why would I deallocate all these inodes? Because I'm just going to go get them back again. Don't know. Depends on what happens under the covers. Okay?
Now you just confused me with that question he said, so can you go with English?
The subtlety was, does this simply empty the existing file, or does it completely throw away the existing file and create a new one from scratch?
Okay.
And the answer is, it doesn't really matter. One way or the other, you end up with an empty new file.
Okay.
All right? Now, I mean, this isn't the only way we could have done this. We could have done this. We could have said, let's do this and nuke it if it exists. If it's not, it creates a new one which we remove anyway.
But that's not clever programming.
But that's not really what we want. What we want to tell the user is, I can't remove that file because it didn't exist. And that might be a different deal because maybe they've run some code and they're expecting some trash files to be left that they're trying to remove. And if you come up and say, you know, temp.1 doesn't exist, maybe they'll go, oh wow, maybe something else doesn't exist. So it's a semantic issue. You know, what's the meaning of RM, a file name? The meaning is remove that file, the assumption being it exists. If it doesn't, well then you got to jolly well tell the user there's no such file. And that's the whole purpose of this little snippet of code at line 23. If the file's not there, tell the user and go away. Okay?
And doing it that way, the user wouldn't know that the file wasn't there?
The user would never know that the file didn't exist because
Okay.
we would have created it.
Okay.
Yeah.
This way, we try to open it in read mode, then if it succeeds, we immediately close it and then remove it. Okay, so it's a subtlety. Now again, the remove command is an operating system command that accepts as its command line argument, as its argument what?
A file.
A file, the name of a file. The name of a file, all right? And what do you suppose it returns? An error code, right? So if there's no error, what's it going to return?
0.
0. And therefore the if will be bypassed because if, what's 0?
False.
False.
Oh, yeah, false.
0's false, everything else is true.
Yeah.
So if, and the return value is 0, everything's cool. Otherwise, what do you suppose is in IERR?
Error.
Some error code. Some error code. And here I've given an example of how the operating system call struct error can be used. If you just print it out, so you tell me to do something. Give me a command. Just give me a command.
Jump up and down.
No, not a Unix command. Just
Jump
give
up
me
and
a
down.
Combine two files.
14. Give me another command.
Create two files.
14.
Yes, you're doing them with just.
I don't know what a 14 is. Now give me a command again.
Create a file.
No such file, which is a more meaningful response.
No such file.
That's fine.
Yes, so what the struct error function does, look at it, string error. It takes an error code that an operating system function produced and converts it into something that human beings can understand.